Hello friends, here we are going to see page replacement algorithm FIFO, LRU and optimal. We'll take the reference string same for all these three algorithms and we will try to find out what is the hit ratio using these three algorithms. Okay, so considering frame size 3 and given reference string, we will solve this. Okay. In the last lecture I have explained you how to solve this using FIFO and LRU, so let's start with this. So the first frame size that is 3, so the main memory, it is having 3 slots, right? So the first page comes in, it is the instance is now 5. Next requested page is 7, as the frame is available, so 7, that is a 7 is initially not present in the frame, right? 7 is not initially present in the main memory, so it is a page fault. So it is requested, it is brought from the secondary storage and put into the main memory, right? Next requested page is 6, again it is not present, so it is a page fault, as frame is empty here, so it can be placed in the main memory directly without replacing any other page. Next requested page is 0, 0 is not present here. Okay, so it's a page fault. So as per the first in first out page replacement algorithm, the page which is there in the main memory since long, or you can say the oldest page, is going to be replaced with the new page. So here the 5 is the oldest page among 5, 7 and 6, right? So 0 replaces 5 here. Okay, next requested page is 7, 7 is already present, so that is a page hit, you can mark that. Next requested page is 1, it is not present in the main memory, it is a page fault. Okay, so out of 076, 7 is the oldest page, so first in first out, as for first in first out algorithm, 7 is going to be replaced with the new requested page. Here it is 1. So now instance of main memory is 0, 1, 6. Next requested page is 7, it is not present in the main memory, it is a page fault. So as per FIFO, out of 0, 1, 6, 6 is the oldest page. Okay, so 7 replaces 6. Okay, next is page 2, again it is a page fault. Out of 0, 1, 7, 0 is the oldest page, so 0 is to be replaced with new page. So now the instance is 217. Next requested page is 0, in the main memory we don't have 0 here, so it is a page fault. So out of 217, 1 is the oldest page, so it is to be replaced with the new page, so instance is 207. Next page is 1, it is not there in the main memory, again it is a page fault. Out of 207, 7 is the oldest page, right? So 7 is to be replaced with the new page 1. Similarly, the next instance 7. Okay, so out of 201, you can see the 2 is the oldest, so 7 replaces 2. Next is the 1, 1 is present, so it is a page hit. Next is 0, 0 is already present in the main memory, so it is again a page hit. So you can see the number of page hits here are 3, so we can calculate page fault. The length of the string is 13, so page fault is 10. Hit ratio is 3 by 13, it is 0.2307. Okay, we'll try to find out hit ratio using LRU, taking same frame size. I can also find out what is the page fault ratio. So page fault upon length of the total length of reference string. So we want hit ratio to be maximum and fault ratio to be minimum. Okay, so that the job of operating system would be minimized. The job of operating system, that is a swapping. If page fault occurs, the page is to be replaced from secondary storage and it is to be placed in the main memory, and while doing so page map table is to be refreshed, so this will take some time. So again we want the maximum utilization of CPU also and memory utilization. For that we are using this paging. Okay, so the hit ratio, if it is maximum, the CPU time, that would be CPU time can be efficiently used. Same example here we are going to see using LRU algorithm. The frame size is fixed, it is 3, and reference string it is also same. The length of reference string here is 13. In LRU, now the frame size here is 3, so the first requested page is 5. Initially the frame is empty. Requested page initially it is not there, so it is a page fault. The requested page is brought in from secondary storage. Okay, as the frame is, as the main memory is available, so we don't need to apply algorithm. Okay, if the frame is you can say the main memory is full, in that case we need to apply algorithm. Okay, next requested page is 7, so the instance of memory would be now 5 and 7. Next requested page is 6, so 5 7, the main memory would be now 5 7 6. So the frame is available here, right? Frame is available, so it is occupied by 6. Next is 0, it is not available in main memory, right? So one of the page is to be replaced now. As per LRU, list recently used page is to be replaced. So out of 5 7 6, 6 7 comparatively are used recently, 5 is not used recently in comparison to 7 and 6. So 5 is going to be replaced with new page 0. So you need to check the distance, the maximum distance in the left side. Okay, so 0 replaces 5. Next requested page is 7. 7 is already present in the frame, it is a page hit. Next is 1, it is not there in the frame. So out of 0 7 6, 7 and 0 recently used, 6 comparatively older, or you can say not used recently, so 6 is to be replaced. I hope this is clear to all of you. Okay, so 1 replaces 6. Next requested page is 7, it is already present in the frame, so it is a page hit. Next requested page is 2, so out of 0 7 1, 7 1 we can see here recently used, and 0 is least recently used in comparison, so 0 is going to be replaced with the new page 2. Next is 0, again it is a page fault. So out of 2 7 1, 1 is least recently used. Out of 2 7 1, 1 is least recently used, so 1 is going to be replaced with 0. Next requested page is 1. Out of 2 7 0, 0 2 recently used, 7 is least recently used, so 7 is going to be replaced with 1. Next is 7. So out of 2 1 0, 1 0 recently used, 2 is least recently used, so 2 is going to be replaced with the new page 7. Next requested page is 1, it is present in the frame. Next requested page is 0, it is present in the frame, so you can say it is page hit. So you can see number of page hits here are 4. In the previous example it was 3. So hit ratio it is 0.30, more than that of what we have achieved in the FIFO. Okay, accordingly the page fault. I hope this is clear to all of you. So here you can see hit ratio is improved and fault ratio it is minimized as desired. Okay, in the LRU. Same example we are going to see using optimal page replacement algorithm. Okay, taking same frame size, that is 3, the first requested page it is placed in the frame in the main memory, so it is occupying the first frame. Next page it is 7, it is placed in the frame. Next requested page is 6, again it is a page fault, it is placed in the frame. Okay, I hope this is clear to all of you, because this is the same as that we have seen in the first in first out and the list recently used. Now next requested page here is 0 and it is not available in the main memory. All the frames are full, right? So here we need to replace one of the page. Okay, in optimal page replacement algorithm, it will see the future distance. The page which will not be used in the future will be replaced. Okay, so in the list recently used, we have seen the list recently used. We have replaced a list recently used page, and we have calculated the distance in the left side, right? Here in the optimal page replacement algorithm, we will see the page which will not be used in the future, right? So out of 576, we will see whether 5 is going to be used in the future. So 5 is not going to be used in the future. 7, it will be used. 6 is also not there in the future. So 5 and 6 are the pages which will not be used in the future. So the page which will be having the maximum distance, okay, in the right side, you can say the page having maximum distance in the right side. Reversely, you can say the pages which will not be used in the future for longer time will be replaced. So out of the 576, here the page 5 is having infinite distance, page 6 is having infinite distance, because both the pages are not there in the future. So we can replace one of this page. So we will apply, if such is the situation, then we can replace the page which is there in the frame since long. So we are going to replace the page 5 with the new page 0. Okay, now next requested page is 7. It is not present here in the frame. So yes, it is present in the frame, so it is a page hit. Next requested page is 1. It is not there in the frame, so you can say this is page fault, right? So we need to replace one of the page out of this 0, 7 and 6. So we will find out the maximum distance in the right side. So maximum distance in the right side, it means that we will see out of 0, 7, 6 the page which is having the maximum distance in the right side. So out of 0, 7, 6, 7 is there in near future, then 0 and 6 is not there, right? So 6 is having infinite distance in the right side. So you can say 6 will not be used in the future, right? So 6 is going to be replaced with the new page 1. The next requested page, it was 7. It is already present, so it is page hit. So the main memory, the frames 071 remain as it is. Next requested page, here it is 2. 2 is not present in the main memory. There is no frame with the 2, right? So we will replace the page which is having the maximum distance in the future. So the page which will not be used in near future will be replaced, right? So out of 071, 0 is there in near future, then 1 and then 7. So 7 is having maximum distance in the future, right? So 7 is going to be replaced with the new page 2. Okay, clear? So now here the next requested page is 0. 0 is present in main memory. There is a frame with the 0, right? So it is a page hit. Okay, next requested page is 1. It is again there in the frame, right? So it is a page hit. Next requested page is 7. Okay, now 7 is not there, so it is a page fault. So out of 0 to 1, you can see 1 is there, 0 is there, but 2 is not there in near future. So 2 is having the infinite distance, so 7 replaces 2. Okay, 7 replaces 2. 1 is present there, so it is a page hit. Next requested page is 0. It is already present there in the frame, so it is page hit. Okay, so you can see number of page hit here are 6. So the count is increased as in comparison with the FIFO and LRU, keeping same frame size and taking same reference string. Okay, so hit ratio it is improved and fault ratio it is decreased as desired, right? Okay, so one thing here to note that optimal page replacement algorithm here, as per the requirement, you can see the future distance is to be calculated, and that is not feasible. So practical it is not implementable, because it is hardly we can find out the future distance, or you can say you cannot find out the future distance which page will be used in the future. That is not predictable. So optimal page replacement algorithm, it is used for performance evaluation. Okay, okay, so just to summarize, here you can say OPT is not possible to be implemented because it requires future knowledge. And here in the OPT, target is the page which will not be used for the longest period. Okay, so for fixed number of frames, optimal page replacement algorithm has the lowest page fault rate. So it is basically used for performance comparison. Okay, so you can say the OPT set the value, and the one which is reaching to the value set by the OPT out of in between the FIFO and LRU, you can say here, because we are looking into the comparison with respect to FIFO LRU. Okay, so it is used for the performance comparison. Okay, so I hope this is clear to all of you. Thank you so much.